Hi everyone, in today's video we're going to be looking at an exam example on Locus. We have already looked at everything that we need to know about Locus, and we are now going to look at an example, a type of question that you can possibly get in an exam. So this question was taken from one of the Namibian national exams. I cannot recall which one now at the moment. We are going to do this as we would, or respond to this as we would in an exam. Before I continue, I just want to make it clear that you want to make sure that if you are given content, that when you are taught and you are given rules and properties and formulas and methods, you want to make sure that that is your weapon. Take it or treat that as your weapon. Like I would always tell my students, you take that as your weapons, and you have to know how to use your weapons to respond to the questions that are presented to you. If you do not master your weapons and study or get to know your methods, which I'm now referring to as your weapons, you are not going to use them correctly. You are going to go to war with Locus, questions on Locus. If you do not know how to use the weapons that I gave you in the previous video, if you don't know what perpendicular bisector means, then there's no way that you would get it right to actually construct anything related to perpendicular bisector, because you don't even know what it means. Therefore, it's very important that if you haven't watched the previous video, that you do watch the previous video, so that we can just lay a foundation that we can actually depend on. Okay, now in this question, we are actually told that the boundary of a park is in the shape of a triangle ABC as shown below. Just before I proceed, make sure that you always make it a must that you have to read to understand your questions. Don't just read to respond, read to understand. So the question is, but before the question, we are told that the boundary of a park is in the shape of a triangle ABC as shown. So you go to a triangle and you see ABC, oh, that's my triangle, and it's representing a boundary of a park. Now, AB is indicated here. AB is 260 meters, while BC is 180 meters, and AC is 120 meters. And like it says here, not to scale, meaning you cannot look at this and say, oh, but there's no way that it can be 180 meters. Of course, it's not. That is why it's we are told that this is not to scale. In question A, we are asked, using a scale of 1 centimeter to represent 20 meters. So what does that mean? It means 1 centimeter is equal to 20 meters, meaning 1 centimeter on the map represents 20 meters in real life. Now they said, construct an accurate scale drawing of triangle ABC. So we are going to use that scale, and we are going to use it to construct an actual drawing, the real drawing, but in terms of now the map drawing of this triangle, not quite there, but the map of this triangle, using the scale of 1 centimeter on the map to represent 20 meters in real life. So now what I want to remind you of is that you were taught in our grades that when you are constructing a triangle, you first draw a sketch, and then in that sketch is what is going to guide you to construct your actual triangle. So now you want to make sure that you indicate the correct distances, the correct length. So as when you are constructing a triangle, so this is just me resetting my calculator. So make sure you always reset your calculator, just to make sure you can rely or depend on your answers, your solutions that you get on your calculator. So now we want to draw a sketch, and we want to make sure that this sketch is going to be in such a way that it will guide us as to how our triangle would look like. So what we are going to do is we take that 180, because we are saying that 1 centimeter on the map represents 20 meters in reality. So if I have 180 meters in real life, then it means I must put the 180 here, doing the cross multiplication. So I have 180 meters here, and I have X centimeters. I want to know how many centimeters I will have on the map. So I'll have 20 times X is 20X, and 180 times 1 is actually 180. And dividing both sides by 20, I have 180 divided by 20, I have 9. So x is equal to 9 centimeters. Since this side was centimeters, this side is meters. So actually here, I must have a 9 centimeters. So what does that tell me? It tells me that in actual fact, every time I want to change from this, from meters to centimeters, from the real distance to map, in this case, I'm going to divide by the 20 that I'm getting. I just concluded that I could have done the same calculation for each of those sides, of the 3 sides. However, it's not quite necessary now that I know I just have to divide by 20. So I'll take 120 and I'll divide it by 20, and I get that, oh, this side will be 6 centimeters. And then I'll take 260 and I'll divide by 20, and I'll get 13 centimeters. Okay, so now I know I have my sketch there. So again, I can redraw my sketch. This is not accurate. I'm just a sketch. A sketch is just something that will guide me. So this is the triangle I'm going to construct. So I have A, I have B, and I have C. So this will now guide me. So I'm gonna do that. Remember, this is just a sketch, right? To guide you. It's not the answer like I'm going to, or we are going to answer on a clean page. Now we know we want to represent this on, in that space. Of course, in the exam you don't have the luxury of having an extra paper to draw on. It's just because of the sake of the video, so that we have enough, space. So now we're going to move this up a bit, because as we construct, we are going to be guided by this sketch. Now we are going to draw a triangle that is true, that it's 9 centimeters on BC, 13 centimeters on AB, and 6 centimeters on AC. So now what do? I'm required to use a straight edge, which is your ruler, and your compass. How do you do this? You take your ruler and you draw the distance like AB first. We're going to draw that first because it's easier to start with that one. So we measure 13 centimeters. You make sure that your sharp end is exactly at 0, and you move your pencil to 13 centimeters. So 9 to 13 centimeters. So then, of course, in terms of the exam, in the space provided, I just couldn't do it there because it's something that I retyped, and I'm not sure if the space is really, worked out in a way that but in an exam, it's an official exam, it will have to be worked out in a way that it would fit there. So we select a point, and that point, just a random point, we're not measuring anything here. We just select the point and we call it A. Then we go to the point we have selected, and we make sure that we put the sharp end. And remember, always confirm that it is indeed 13 centimeters. It's indeed 13 centimeters. And if you find that it's not, fix it to be 13 centimeters. Okay, so you put your sharp end. Put your sharp end there, and you make an arc there. What does that mean? It means everything on that arc will be 13 centimeters from A. And you go anywhere on the arc that you have just created. It doesn't have to be a long arc, no? And you make sure you are on the arc, and you go back just to make sure you indicate that, oh. And then you take your ruler and you connect it to the other side, and you're going to where the arc meets the line, the straight line that you're going to draw, that's where your point B will be. So that is your point B. Now that is the first line. So you have constructed the map distance of the actual 13 centimeters of the length AB. Then now we want to locate or to see where will C be. C will be somewhere in this area, but we want to make sure that it's in the correct position. So we take our ruler, and then we are going to measure. It now depends whether you want to go from A to C first or B to C. We can start from A to C first. And A to C is supposed to be 6 centimeters, right? So we are going to put the sharp end at exactly 0, and we move, and we put our pencil at 6, and that means the distance between the two is exactly 6 centimeters. So we then come, and it means we confirm again. Just want to confirm because we are guided by our sketch, but we want to confirm and make sure that we are accurate. And then we now see that it's 6 centimeters. So what does that mean? We go to where we have positioned A, and we make another arc on the side. Not too long, but not too short either, so that I can it can intersect from the other side as well. I've seen that that is 6 centimeters from A, and if I want, I could confirm this is indeed 6 centimeters from A, and I can go all the way and I'll see that it's indeed 6 centimeters. Anything on that arc will be 6 centimeters from A. And just before I forget, let's not forget to indicate that this is indeed 13 centimeters. Then we are now going to construct from B to C. And what does our sketch say? Our sketch says that from B to C, we have 9 centimeters. So we are now going to take our straight edge, aka our ruler, and we are also measure 9 centimeters. Make sure that your sharp end is exactly at 0. Make sure that your sharp end is exactly at 0, and we measure 9 centimeters. Now I have 9 centimeters. Confirm it again. Confirm. Confirm that I have 9 centimeters. And then come, and remember 9 centimeters is B to C. So I'll come and I'll put exactly where I have positioned B. That is where I will put the sharp end. That is where. Now, do you see how risky this was? But it's so close. However, it's advisable that you construct like your arc a little bit, just a little bit longer. You can always clean it up later. Now it means anything on this arc is actually 9 centimeters from B. It means where the two lines meet, where the two, not lines, but two arcs meet, they meet here, and that there where they meet, it's going to be 6 centimeters from A. We are going to have C there. We have 9 centimeters from B, and then here we'll have our C, and that is 9 centimeters. It's advisable that you make your arc just a bit longer, but what matters is that you see that they intersect. You are allowed to clean it up a bit if you feel that your arcs are too long. Maybe you are allowed to clean it up so that those arcs don't interfere with what you are going to present. So I'm just quickly going to redo this with a pencil, because I don't want us to work with an ink pen, because then we are not going to be seeing what is going on here. Okay, just quickly recap again. So we are now going to respond to these questions on this. The only way you can predict your future is to create it. Just a word of inspiration. Okay, now continuing in B, we're supposed to, for 2 marks, we're supposed to do the following. Inside the triangle, construct the locus of points that are 4.5 centimeters from point C. So what you're going to do is you are going to take your straight edge and you are going to measure 4.5. We have 4.5 exactly between 4 and 5 there. So we have that is 4.5. So what do? You take your compass, you come and you put here 4.5 centimeters from point C is supposed to be something like this. But remember they said inside the triangle, right? But before we continue, we'll say this is our answer to B. And we are going to clean it up. We can clean it up because we don't need this part. Because remember this is construction. And if we are given, I'm going to erase the 13 and rewrite it again. But if it's construction and you end up constructing, this is your plot, right? ABC is your plot. Now, if you go and do your constructions outside, okay, so we have our solution to B. We have constructed a locus of points that are 4.5 centimeters from point C. So that is what we have, 4.5 from point C. In the next question, they said, in C, they said, using a straight edge, aka our ruler, and compasses only, construct a bisector of angle ACB on your diagram. ACB. Which one is ACB? ACB. Angle there. So what do? This one we don't measure anything, remember that. So we are going to turn it around. ACB. Then we know we are bisecting that angle. So we are going to do that. Remember what I said or how I taught you or showed you how to do. If you haven't watched that video, please go and lay that foundation before you come here. So we do that and we can do that. We do that. Then we extend it a bit just so that we are inside the arc. Then we come inside the triangle. We come and then we do that. And without changing the size between your sharp end and your pencil, you go to the other side of the arc you created earlier and you do that. And then you have an intersection taking place. You take your ruler, aka your straight edge. You connect the vertex of the angle that you are bisecting and you draw your straight line until where the triangle, and don't end where the intersection is taking place, until the whole inside of the triangle. So that is our answer to C. Now we have responded. So back, if we turn it, you are allowed to turn your paper around, your question paper around in a way that fits you. Remember we said we also don't want to just leave lines. We want to leave our arcs as neat as possible, but leave those intersections because you want to show that you have done it the correct way. We can erase it and just write it in a way that we can all see. You can write it in a way that you can all see its answer to C. And then we go to question D. Says, using a straight edge and compasses only, construct the locus of points inside, emphasis on inside your triangle, which are equidistant from B and C. What does that mean? B and C. So what do? Remember here, equidistance is also the same as equidistance from 2 points is also the same as perpendicular bisector. So this is what we do. Then we make sure that the pencil is a bit closer to the other side than it is to where you're coming from. Then you create your 2 intersection. You can do that. It's just that I don't want to mess up or make it messy. And then you come to the other side. Just make sure that there is an intersection that will take place. And you come and it will be like that. So that is what you have. You come and you are guided by those intersections. This intersection of this arc and that intersection on this arc. And you come and you say, oh, it's here. Come and draw there. I'm guided by those intersections, but I don't get this confused. and you are allowed to do that. You change it and you write your B next to this side, because just because you see now it's mixing up with my D, so then you come and write D next to this one instead. Looks messy. D. So that is our answer to D. And then we go to the next question, and the next question is saying flowers are planted in the park so that they are more than 4.5 centimeters from point C. So this B was the one that is 4.5, so more is on this side, so it means it has to be this part, this small part, and also from this arc, this side. It must not go there. They also said the same flowers should be nearer to C than to B. So this is the line separating C and B, exactly in the middle. So if something is nearer to C, then it must be this side. So it's this side of this line, should not go beyond that. And so it's this side of this line, including this part as well. Now we want to make sure, before we sheet it, we want to make sure that we have satisfied all the conditions provided for us. The other one is that it should be nearer to AC. Which one divides AC and BC? AC, BC is this line. So it should be nearer to ACE. So if something is in the middle, anything closer to AC than to BC will be this side, because this is the line dividing it in the middle. So it means it's only this side. So it should not then be that side. So our flowers are just going to be planted here. Remember to restart the video, rewind, pause, try again until you are able to solve it. And then that is going to be your answer to E. This one is your answer to E. So that is how you're supposed to respond to this type of question. Remember to pause, try, and then you continue to see if you're right. Now that you are given a video that explains how you do each individual one, and remember, just to recap, perpendicular bisector is a line that is perpendicular to this one, perpendicular to the given line, but it meaning it divides, or it's perpendicular meaning it creates a 90 degree, but it also divides the two into two equal. So if this is 5 centimeters, then it's also 5. This is 4.5, 4.5. So that is how you should do it. And remember, bisecting means dividing into two equal parts. So bisecting an angle means dividing this angle into two equal parts. And then you just follow your instructions when they want you to shade something. Thank you for watching. See you in the next video.